Hello chaps and chapettes, and this is going to be one of our last component videos and also the last video on logic gates. And we're actually going to look at 3 today, even though I've only listed down 1 in the title here. First of all, you need to know what a NOT gate is, and that's really quite simple. At least in understanding, it's quite simple. The actual application of it is quite tricky. We're going to understand how to combine NOT and OR gates, and be able to draw the symbol for a NOT gate and produce the truth table for a NOT gate as well. The challenge today, or as a result of this video, is to design some logic-based circuits, which means that you are going to engage in a little bit of really basic computer programming, and we'll go from there. So the NOT gate is really simple to understand because it only has one input, and what it will do, it will give you a reverse output depending on what input you've got. So just to reiterate that and make it a bit simpler, if you've got a low voltage coming in, you'll get a high voltage out, and if you've got a high voltage coming in, you'll get a low voltage coming out. It basically reverses the whole thing around. And there we go. So I'm going to show you this now in a circuit. It's going to look really kind of complicated, but it's one of the only ways to do it without having an actual purpose-built NOT gate. So let's go into it now. Right, so this is my ridiculous setup for a NOT gate, and it does require a little bit of explanation first. What we're going to do here is essentially going to do a short circuit for this light bulb. Right now, the NOT gate is in the off position, which means that is essentially a 0 voltage going in, and the light bulb is on, so off, on. Now we've got this resistor down here because what we're going to do is we're going to put this into the on position, and of course the light bulb goes off. The current now is going through this switch here because it's the path of least resistance, and that's why we've got this resistor here. The voltage is now being dropped across this thing, so we don't have any sort of dangerous effects going on. So off, light bulb's on, light bulb's off, and there we go. That little setup there is a NOT gate. This is just a little bit of safety whilst the light bulb is in the off position. So there we go. Just to show you what a NOT gate looks like, I actually don't have any. I do have these, a NOR gate and a set of NAND gates, and these actually function as NOT gates on their own. Basically for a NOT gate on an OR gate, all you do is you just combine these two, just attach these two inputs here, and that will turn the whole thing into a NOT gate rather than a NOR gate. And to explain what a NOR gate is, well, I'll explain what these two things are in a second. So there you go, that's the NOT gate, and it's a very simple thing to do, simple thing to draw. It looks very much like a diode, but instead of having a bar on it, we now have a triangle and a circle. And whatever is coming in the input on part A, it will give you the opposite on the output of X. And there you go. Where this gets interesting is where you combine it with AND gates and OR gates. And what that means is that it gives you the opposite effect of an AND gate or an OR gate. So looking at the AND gate here, we put a NOT gate right on the end of an AND gate. And that means it will give you a 0 voltage or a low voltage, a 0 value, if both of your inputs are high. So it's basically the reverse of an AND gate. The NOR gate is the same thing. We put a NOT gate on the end of an OR gate, and what that will do is it will give you a high voltage if both your inputs are 0. And that's going to be quite useful for various different circuits. So I'm going to leave that up to you actually, as part of your challenge. I want you to think about how you could use these things for logic-based circuits. Just make sure before you do, you know what a NOT gate does and what it is, and understand how you can combine it with NOT and 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 OR gates. Make sure you can draw the truth tables for all these different setups, because that will be quite important when it comes to exams. And there we go. I look forward to seeing what logic-based circuits you come up with. And when I say that, I want you to think of what puzzles and problems you can solve by using these components. Alright guys, I'll catch you in the next video.